Beep, beep, beep. Can y'all hear the beeps? Hopefully it's not too bad. I can close the window if it's really bad. Beep, beep. Is it really bad, Mark? I have the window open and they're just like putting gravel in the driveway for the house next door. Is it like super loud or not too bad, or let me know. I know it'll stop when they stop backing up, but I think they're gonna keep backing up over and over again. It's like a bulldozer that's rolling over the driveway. I don't know how late they're gonna. If it's too bad, I'll close the window and I might just get hot. But and I have the fan on as well. I'm a little worried that I'm a little worried actually that if I lock myself in here, not only will I overheat, but like my laptop and the camera is going will overheat as well. So yeah, and it's not a truck. It's like I could try to point it out the window. It's like a bulldozer style thing. I wonder what setting my mic is on actually. Let me see. Yeah, I think it's the mic is on the one. I don't know if I can stand it. It's a little beepy beepy. Oh yeah, thanks for noticing, Abominable. I cut my hair. I like cut it myself. So if it looks bad, it's because I did it myself. But it feels much better. I don't know how much more work they have to do. I don't know. Welcome to my life. Awesome. Cool. Somebody wants to know how I can earn money. Jonah's voting. I'll close the window. It's fine. I might open it later once they stop. That should be a lot better. With the windows closed. Let me see. How did I have this arranged? Yeah, it's late for you, Mark. No worries if you have to go early. Alright, cool. Oh, you know what? I didn't put OBS where I usually do. So let me do that. It's like the time that they were like cutting the trees next door during one of the CircuitPython meetings. Oh, thanks, Mark. I'm sure my computer will stay cool because you turned your fan on. It's going not too bad. I had something leaning up against the bottom of it, and I removed that, so hopefully that'll insulate it less. Probably a bobcat. No, it's got a deer on it. It's a John Deere for sure. But that's the only way I know, is that it's got a deer on it. Oh, okay. So this is not what we're going to talk about today. You can't see it anyway. Let me do my fancy thing, and I'll get going. Hello and welcome to this deep dive with Scott. I am Scott. I go by TanNewt online and on Discord. I do these streams usually every Friday at 2 p.m. Pacific, but if there's a holiday of some sort on Friday, then I will usually do it on Thursdays at 3 p.m. So keep an eye out for that. Maybe next week. July 4th is a holiday in the US, and I think it's over the weekend. So keep an eye on the blog. What I try to do is I try to blog the day before about what time I'm going to stream that week. So keep an eye on that. If you're on Discord, you're welcome to ping me as well. The plan today is, I was debating here. I can take a poll, an informal poll here. There's two options. One, I can recap the work that I've done on the ESP32 over this week, or we can just dive in because I'm actually like debugging a bug right at this moment. that I've got to fix. So if you want to recap, I don't think it's going to take too long, but I think that the recap mode gets me into talking mode, which, as you know, last week got me talking the whole time. I think that's probably the better thing to do. So, and I don't think it's too much. So if I just pull up my GitHub repo and let me switch cameras. So this is just my repo and it looks okay. New GitHub design. Branch. ESP32-S2. Debug your bug, says Mark. Because he has to go to bed, so he wants to see what the bug is before he goes to bed, I assume. I don't know, actually, like, what is an easy way to see, like, the last so many commits? Because I guess I've got... Okay, so this, I'll just do a short recap based on these commit messages. How about that? And then if there's any specific parts of the code that we want to go over, we can do that, because we will be in that code. Uh-oh. Has my overhead... Oh, you can't see my overhead. I paused the view. Hi, Evan. Thanks for hopping in. And Mark and Jonah and Charles. Thank you all for being here. I appreciate it. Okay, so let's just look at these commits and we'll do a fast recap. Yeah, Mark wants to deep dive. Okay, so hi, Summersoft. Basically, last week, what I spent a bunch of time talking about was just like the memory trade-offs and keeping track of the memory that the ESP IDF allocated that we were using from CircuitPython and making sure that once CircuitPython didn't need it more, we would actually free it. So what I did is I actually made it compile. So I fixed some compilation issues. I handled the memory, and then I switched from... I got it working, but I got it working without DMA, and so I got it working with DMA. Good morning, Unexpected Maker. So I got the screen display working, and I also did this thing that people would be very interested in, is I turned off the idle watchdog timer, which allowed me to change in the delay, or no, in the background task, we had this like one tick worth of delay, which turned out to be 10 milliseconds. And so I was like saliating the SPY transactions and noticing how slow it was. Like, I think I did either on this stream or on a show and tell, and it was like really slow. So I changed that, and it's way quicker now. So anybody who is actually like starting to see performance of it should see a big improvement with this commit there. And then today I spent debugging a couple issues that I was having. I was actually like, I have this big long list of stuff to do because I was like kind of overwhelmed with everything I had to do yesterday. So I've made a list, and as you can see, I've crossed most of them off. They're not all technical ones, but I do have test UART-TX and test SPY RX on there, because when I had tested UART, I had only done it with the GPS, which is receive only, and when I was testing SPY, I was doing transmit only because I was just doing a display. And so I was like, oh, you know, like, I suppose I should do like basic testing before I make a PR for it. And so I was trying to switch over to the BME 680, which I can switch to this. And you can see, hopefully that's live, yep. I've got my Featherwing adapter, and I'm doing a SPY connection to this BME 680 sensor. And so I was like, great, like this should work. If it transmits right, it should work. Receive should work just fine. It turns out that's not the case, and even more so, it turns out that I wasn't actually able to test that today until I fixed two other bugs. One of the bugs was that when I create the SPY device, I wasn't actually storing the host ID, so like whether it was SPY2 or SPY3, which meant that when the display code went and said, hey, never reset this particular SPY, it was actually resetting that particular SPY, even though it shouldn't have been. So I added that and I fixed that. It was showing up as this like kind of crazy like lock assertion error in the IDF. And it was because I had added, let me just show you this code. Not this code, not this code, but this code. this is the common HAL file for SPI. And basically what I'm doing is I'm holding on to the pointers that the IDF is allocating for me and matching those up, because I can only create one SPI object per like SPI2 and SPI3. I just store the pointers externally as well as in the CircuitPython object. And so I either, when you deinit the object, will we delete it, or at SPI reset time will we actually free the IDF resources there. And what was happening is that I was correctly resetting both SPI devices and their locks, except for the fact that I meant to never reset one of them. And so I was continuing to use it after I freed it. And that was bad, and it was crashing, and I figured that out. And then the other issue that I discovered, this one is for the digital in out, when we did it, when you deinitted it, we were setting pin to MP const none rather than null, and I've switched it to null. And the reason is that the display code always creates an object for the digital I/O for the backlight pin, and in my testing, I realized the display I was working just automatically turns the backlight on. So I wasn't giving it a backlight pin, and it was trying to free MP const null objects, which was bad news. So I switched that, and that fixed that as well. So I could finally get, this morning, once I figured these issues out, I was finally able to get to the point of swapping to the BME 680. So let me just switch to the overhead. So just to recap, what I've got is the Sala is underneath here. This is my Feather adapter. I've got both USBs plugged in. I've got an always-on USB, like short USB cable connected to the Sala debug UART for flashing. This is very similar to like how I de-init ed, like whether it's de-initted. Oh, it's bringing me back to my ACNAC days, which maybe is the problem. I don't know. And then going back to here, I've got on the native USB port, I've got my fancy USB cable that I can click on and off. And then the setup that I have is that I've got power and ground going to the BME 680 along with MISO MOSI clock and A5, which is what I'm using, which happens to be IO8. And then I've also got the Salier hooked up off screen here as well. So that's, I think, kind of where I'm at. Are there any questions about that? Did I gloss over anything too much? Basically, I really hope to get a PR out today. It's actually one of the things on my list is getting a PR out for Bus.io today, because it's been so long. It's been so long that I've been working on it. I've just got to finish it. And the last two items I had were testing UARTX by RX, and then going through all the code and making sure there wasn't like any leftover debugging stuff or anything like that I hadn't implemented that I do need to implement. So I'll have to do that as well, but after I test it. Sorry, I can't. Clear as always. Debug ready. Okay, thanks, Bruce. Okay, so where I left off. Thanks, Unexpected Maker. Yeah, those issues were kind of a pain. But you know, I really had no choice. I had to deal with them. And Alvaro says, very cool, a bunch of devices should now work. Yeah, I think all the displays will work, which is great. I showed that off on Show and Tell on Wednesday. But unfortunately, so let me show you the test code I was running. And I think the test code is correct. I have because I have a giant monitor, I actually have 3 separate windows for like different related files. But so let me just show you this. Which camera is glitching? The overhead? I don't like this overhead. I'll switch away from it anyway, because that reminds me I'm now showing you a file And I should be on here. In fact, I'll just do browser stream so that all the chats show up. I know that I'm just happy the camera's kind of working and not frozen, so I'm gonna go with it. So here's my test code that I'm doing. Yeah, Mark, the screen is flashing for some people. This camera is not the greatest. So I'll turn it off. Sorry about that. Okay, so here's the demo code that we're doing. We're doing a bunch of imports. We're setting up the SPI bus. We're setting up the chip select pin and then passing it to the SPI version of the BME 680 drivers. I also turned on debugging because I wanted to see the transactions that it was doing. And then hopefully we would just be printing out how hot it is in here. Which the longer we wait, the hotter it's going to get. Although it does kind of look like the guy who was driving the thing is no longer driving it, so might be able to do that. No worries. I think there's the least latency probably with Discord. If people want to, oh yeah, I never did my housekeeping, did I? Most of you know the drill. In case anybody's new, the chat that we have all week is at the URL adafru.it/discord. Hop on there. We're in the live broadcast channel for that. The cat who's sleeping on the floor behind me does have seizures occasionally, so if I am like muted and just standing in front of the camera, I'm just watching him, and we'll be back shortly. And I'm paid full-time by Adafruit to work on CircuitPython, so if you want to support me, you can support Adafruit by going to adafruit.com and purchasing stuff from them. They're working their hardest. They're working really hard to get everything back in stock now that they can make stuff. So please do that. And thank you so much to Adafruit for continuing to pay everybody, even though they were not manufacturing or selling products themselves. So don't forget that. They're awesome. Okay, back to where we were. We have this demo code, and the error that I'm seeing, I think I can turn it on. So where's my terminal? So this is the debug output here, and then if I click it on and rerun it, so I'm just doing Control D, we can see that it failed to find the BME 680, and it says that the chip ID it received is FF, which is unfortunate. And in fact, when I first saw this bug, it was 00, which is also unfortunate because let me just ignore that. What I'm gonna do is I'll start the Salier, and I have it set up here. So the yellow line is the chip select / enable pin, and I have it set to match on a falling edge. So basically the first transaction, it will do that. So if I just go back here and do a Control D, we should be able to capture these like 4 transactions that happened. And yeah, it stopped. Okay. So let's hide those and zoom out. And here we can see the 4 transactions. So there's one here, which is a 73 and a 0. And so the green line is the bits going from the host to the selected device or peripheral. We had a big debate about that, and I think we settled on host and peripheral. So we're actually doing CircuitPython 6.0 because we're renaming I2C slave to I2C peripheral. So keep an eye out for that if you haven't seen it. So in this case, the green line are the bits going from the host to the peripheral, and the blue line is the reverse. And these first 4 are actually just writes. They're not reads. But this one here that's split apart is the D0 is getting the chip ID, and then the next byte is supposed to be received from the selected device. We're gonna do MOSI and MISO still. We're just calling, we're redoing the acronym. We're gonna say main input, selected device output, that sort of thing, or selected peripheral out. And that was actually a suggestion from Dan. I think it was Dan. Let me look. Somebody actually followed up after our discussion. Rob. Sorry, Rob. Rob suggested it to me on Discord, and thought it was a great idea, so we went with it. Oh no, my audio's out of sync. My CPU usage is definitely at like 30% now, which could explain it. I bet the computer's just hot. I bet it's 30% because it's trying to shut stuff down. I'm gonna disconnect the overhead. If things go haywire, I'll be back. But I'm just gonna turn this off. That'll like reduce the number of streams. Oh, you know what it's probably is? It's probably also running the Salier. But I'll turn the overhead off now that I already showed it. And hopefully that'll help. Oh yeah. Oh yeah. Now my CPU usage is 4%. Yeah, I'm just a small person in the corner. So if it gets better, let me know. That's good. It looks like the CPU usage on OBS got better, so hopefully that was it. But I won't be able to show the overhead anymore. Okay, so this is the problem, is that we should be receiving a 61 and we're receiving an FF. And I suspect for some reason that I have not figured out yet that the SPI code I'm calling is reading the state of the MOSI line, not the MISO line. And the reason that I suspect that is I'm actually, since I'm going to be like recompiling CircuitPython, reloading it. Okay, great. Awesome. Glad that helped. Okay, so since I'm going to be recompiling CircuitPython, loading it, and then starting up again, I'm actually going to disconnect the USB. And I can do that because in the output here, I put debug statements. And I put a debug statement that basically prints out the first byte of the data that I'm getting in over SPI. So without actually connecting to the device, like the code.py will run once. So without being connected to USB, I can see when I fix it. Which is a neat trick and super handy, because otherwise if you leave your USB active and connected, you'll end up like really kind of like choking your USB bus. And I noticed it the first time because I was like listening to music over headphones that were transferring the audio over USB, and you just like start losing your audio because your USB bus is like trying to communicate with a device that's no longer there. It's like in this weird state. So this is what we're going to watch for. We're going to watch for a 61 coming in this spot here. And what we'll also see is that like the driver should pass its check and actually make more transactions as well. So that's what we're trying to debug. Any ideas? Anybody know exactly what this issue is? Otherwise, I'll show you what I was thinking. So the first thing I wanted to check was maybe I have a copy and paste bug. Maybe I am actually setting like the pin number for MOSI and MISO to the same thing. So I went and double checked this, and then I also added this logging that reads it kind of back out of that bus configuration file of what the numbers are along with what the flags are. And when I looked at that, or when I printed it out, which happens right here, like you can see that MOSI and MISO are different. So that's less likely to be the problem. Until we fix it, I don't know whether it's actually the problem or not. Mark, you troll. Mark asks, did you check the example code? I didn't, and I am planning on it. But the example code I'm planning on checking is actually like, because the code that I have in this file is not directly like the driver level API for ESP IDF, I've got to actually dig into IDF code, not just the examples. But yeah, that's a good idea. There's these SPY common bus flags, which I don't know exactly what they do. Bruce is trying to fix their build. I've got 2 glasses of ice water. There's a backup one that I put extra ice in. Ah, David says, did you verify that you can read both 0 and 1? No wine with work. I feel you there. I can't, if I have just like even a beer, I'm just like hosed. I can't do it. Yes, I know that I can get zeros and I know I can get all ones. And the reason that is one thing I'm not clear on what it does is the half duplex setting to the HAL. And so I just tried switching it. It was originally 0, and I can just show you what happens here. So let me rebuild and rerun. I added this Flash CircuitPython only target as well, so that it will preserve like the UF2 portion of the disk. This glass is dripping everywhere. All right, so we're starting up, and now the 1 byte we get in is a 0. And then the other thing that I also checked is that this 3, let me just show you. I'm also setting the first byte before I make the transaction to something that's not 0 or 1. So data in here is set to 3. You can see that I'm printing what the transaction settings are. Sorry, let me scooch it over. So the transactions, I'm saying like how many bits is it and where is it going? Like what is the data in thing? What is the receive buffer? And what is the value of the first byte? And so if we look back here, we can see that I am setting the first byte to 3, and then after the transaction is done, it's set to 0. Yeah, Fede2, there's a way to remove the, there's a way to override the port. Somebody added it. You can just say port equals something else. I mean, we should all be using UF2 anyway. Even if you have other CircuitPython boards, it will not flash them because ESP tool will look for the ESP32-S2. Okay, so the other thing about this is that this first version of the logic analyzer shows that MOSI is high, but I switched the half duplex. So let me just rerun it again and show you that with the other half duplex setting, it sets it to 0. So if I just rerun it again. That MRAM, like the chip that Lamore had for Ion NPI, is pretty interesting. It's like super flash, non-volatile memory. It's just kind of expensive still. So here we have the 3 and the 0, and then we caught it on this Logic Pro, and we zoom in, and now we can see that with the half duplex setting 0, MOSI is actually low for that period, which is what makes me think like somehow like the mux is set wrong, so that the SPY is reading the wrong pin. Unfortunately, I don't know if I covered this last week, but the SPY section of the technical reference is actually not available yet. So there's no public proper like documentation proper about like what I would do next, and I'll figure out how to do probably, is read the registers that configure the pin muxing stuff to see if I can figure out like what setting is wrong. But it's going to be a bit trickier because the technical reference, which in Sandy land is included in the datasheet. Doesn't actually document the registers at this point. However, there are like structs in the IDF that you could look at. Yeah, Dylan Rice says, I'm excited for when people will start putting MRAM in dev boards. Yeah, I think it's just a matter of price. Just the price has got to come down, and then I think we'd see it. But in CircuitPython, Max Holiday actually added some tweaks, made some tweaks to CircuitPython, so you could make one now to use MRAM. He works on like low cost satellites, and it's better for radiation stuff. Okay, Mark says 2 extra APB clock cycle periods should be added to the MISO delay if the master uses the GPIO matrix. I think that should be accounted for because we're still calling clock config. Like this timing config stuff is being determined by the IDF. Right. Alvaro says a friend from Spain also bought some MRAMs for balloons and nanosatellites. Yeah, so I think it should be doing that. Because we are using the GPIO matrix. David says, a few weeks ago, you moved the Python script to a working CPU to look at the correct waveform. But I think this is the correct waveform. Because the device is controlling, like, what the host does on output doesn't really matter. The device should ignore it. Instead, like, we should be reading this. Because it's a read. So I think the waveform's correct. The reason that there's like these gaps here is that I'm printing. These are actually printing gaps. Because printing is really slow. So yeah, I think it's I think the device is giving the correct output. We're just not getting it in somehow. So let's see. One thing I want to try actually that I just thought of is I just want to take one thing that I've had to redo is the order that I define things. So I think what I want to do is just bus config is used here and bus config is used here. I want to actually just print it out after I initialize the bus because it's possible. Oh, you know what? Let's also do this. We're checking for 2 different results, but let's make sure that it is actually okay as well. So let's just say ESP okay. It's possible it's giving us an error and we don't know it. Yes, I believe that it is reading the MOSI value when it should be reading the MISO value. So let's plop there so it always shows up, and then we'll add a an error message here as well. Maybe it is actually failing and I just am not checking it. Error results. And we'll do E so it's that. How's everybody's week? Going good? We're making progress on Election Cow. Ask Patrick has been helping add more election dates, which has been great. And it doesn't look super terrible. Okay, so let's see here. This looks all the same. And we're not getting the error message, so it does look like the initialization worked okay. Let's see. The one thing I didn't check is that there is this flag thing. Common bus flag MOSI. Let's just pull up. This I'm going to move off screen. You don't need to see the sample code again. I already have too many windows open. Where did my other... Election cow. That would be a better... it's cal as in calendar. But yeah, election cow is like actually pretty funny. Like maybe it should be called election cow. I was thinking a tagline for it would be voting information for procrastinators, like people who wait till the last minute. Charles says, what pins are you using? You said that some pins don't go through the IO mux. Yeah, so I'm using 35, 36, and 37. And they aren't routed directly through the IO mux. They're routed through the GPIO mux as well. Oh, where did my other window go? My ESP32-S thing. There's this one. Oh, here we go. It's so hard working on a tiny portion of my screen. Okay, so in common, let's just see what miso stuff there is. Somebody else has put, when we were talking about miso, we got a miso soup posted. Miso needs output. We don't have bus flag duo. It checks the pin and it's fine. Temp flag. Set flags for dual mode according to output capability. What? I don't want to be in dual mode though. Mark says, election cow, don't procrastinate, get a move on. Oh, terrible, 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 terrible. If missing flag does not equal 0. Okay. So that's just doing our pin checking. And that's okay. We're not using IO mux, we're using the GPIO matrix. If miso number is greater than 0, which it is. Oh, you know what? This is what we could do. We could just read these things and see if they're correct. Pin function selects. Let's just see. Let's just snag this and we can, this way we'll be able to validate it ourselves. Because that's what I suspect is wrong. Dylan asks, is the does not equal symbol a Mac thing only? It is not. It is the font that I'm using that is doing it. And it's called ligature. So I'm using a hack font. No, yeah, it's the font that's doing it. So you can set it up to do that too. And it does these pretty arrows as well. How updated is GitHub with your code? It should be up to date, except for the debugging. So if we git status, it should be just like a super minor logging tweaks. For a code, thank you, Summersoft. Fira code. Yeah. Yeah, so just the debugging stuff is not on GitHub. Everything else is up to date. So if you want to follow along at home, you can. Yeah, Summersoft asked last week. All right. So I snagged that stuff, and that's just the check. So let's go back here, and let's do it in transfer. I wonder... Yeah, Dylan says, oh, nice, I need to check that out. Definitely cleans up syntax a good bit. Yeah. I'm pretty happy with it. I've gotten used to it for sure. And it still works like the two characters. Like, even though I can put my cursor in the middle here, if I delete, then it's the exclamation point. I don't know how to show that because it makes it disappear. But okay, so I just want to make sure, like, it feels like, yeah, Charles says ligatures are two characters that get turned into one character. Good way to define it. So let's just paste all this stuff here and see if we can't just, I don't think we have bus config anymore, but I think it was, we have it printed out. I think it's pin 37. Oop. I think it's pin 37 and we can just hard code it. That's the beauty of debugging. Like, debugging and then with Git is awesome because you can, with Git, it's really easy to undo all of the like hard-coded stuff that you've done. So, yep. Yeah, Miso's 37. And I think there's a GPIO get direction. Maybe not. I had to do some fancy things with this. But like it feels like it's reading the wrong pin, like it's connected wrong. There's also this GPIO pinmux reg thing. And it's possible that that is incorrect as well. Hi, Gabriel. So I think we should just start from the outside in and see if that works. Why would you send that? Is your cat on the keyboard? GPIO input, okay. I think we're gonna have to add an include, but we can do that. Yeah, Charles asked, doesn't CircuitPython usually ignore the hardware chip selects and allow you to use any pin for CS? Yes, it does. That is not the problem we're having. CircuitPython uses digital in-outs to do the CS pin select stuff. This exists, right? Or am I making this up? It appears I'm making it up. How did I do it in digital in-out? Get direction. Oh, here you go. HALs don't have a lot of introspection APIs. Dooba dooba doo doo doo. It's this edit reload cycle at this speed where it's like CircuitPython is a step above it. It's just much quicker. Okay. So that one's right. So let's take a further look. I think. Let's see if there's a way to do this. So the GPIO is okay. Okay, so this is in the ROM. So it's components ESP ROM include components ESP ROM include ESP32 ROM GPIO. Matrix in. So this is just setting again. And is there a way to get it? This is why I like just register level stuff. Like, I want to read the thing that it's doing, not write it. I want to be able to verify that it's what I expect it is. Sample the value. Sample the value. And it's in the ROM, so I don't even think I can tell. Right? Like, I don't actually have the source of this stuff, I don't think. Matrix out, matrix in. Whether the signal is inverted. Doesn't return anything. One GPIO can input to several signals. Can this ESP transmit FM? I don't know, but I would assume not. I really don't know. The keyboard I have, TG Techie, is a keyboardio. And I like it because it's split. Can it be used as a transmitting jammer, not as a deauthenticator? I don't know. I'm relatively new to all this radio stuff. Okay. So how do we validate that the matrix input is actually correct? Here's a static inline. Oh, look at this. What do you think this is? GPIO matrix in check is. You think that actually makes sure that it's the same? Components, driver, I2S. Mark, switch to Discord chat. I believe so, yes. Mark says, I switched to this chat. I just wanted to check that the 0x61, is that the value from this peripheral or sensor? And on the logic analyzer, it shows it correctly on the NISA pin, but it's just the ESP32 not reading it correctly. So it's almost certainly that the sensor and the wiring is correct. Yeah. All the wiring looks correct to me. SDO is blue. Is it blue and... yeah. And blue goes to... uh-oh. Oh yeah, my blues don't match up. So yeah, it goes to miso. And if the other one wasn't right, then the device wouldn't respond correctly. So like the output direction definitely has to be correct in the way I wired it. I don't know. It's probably something stupid. Something simple that I am just not seeing. What the heck? What am I looking for? Matrix in check, line 127. I must be in the wrong file. Components, drivers. Oh, I'm in I2C. I2S. Oh, it's just making sure that pin function select. Ah, so annoying. GPIO matrix in. Yeah, I thought so. Just wanted to double check. If it's the sensor sending the 061, then it must be receiving the commands from the host. Yep. That's my conclusion too. We can just try setting it again. Input enable. Let's just try doing all this. See if it changes it. I don't know why it would matter. But it shouldn't hurt. Oh no, where did I type that? Oh, what? What happened? My terminal's not happy. Oh dear. Oh dear. What did I do? I pasted a ton of random stuff. I'm like printing election calendar stuff. Stop. Oh no. Don't worry, I'm a professional. What is it doing? I hit some random combination and it was not the right combination. What did I do? It's like dumping all the HTML from election calendar. Control C. I can close the tab. Die tab, die. And start a new one. Sorry about that. I don't know what I did. Oh yeah. Sparky. Luckily there was no actual blue smoke that was let out. Hi Omar. Why are you putting one word on every line? Don't make me ban you. Generation says programming and circuit building could be frustrating. Indeed. It can be frustrating. It takes a lot of persistence. Ooh, that's cold. Quick type get status. I always type get status. Get status. I'll do it in GDB. Okay. Is this a terrible gift? I've been wielding my band hammer plenty, so beware. Brain fart. That's so frustrating. I don't know what it is. I don't know what it is. What do you think Funk GPIO comes from? Funk GPIO underscore GPIO. Abominable, I got your back. Spammers be spammers. Moderating's so fun. I wonder if the logic analyzer is showing correct data. Something between isn't right. The GPIO matrix is one part, but what about the DMA? Maybe that's not correct. Maybe it's not being transferred correctly. Yeah, that could be it. What makes me think it's the GPIO matrix, though, is that the value that ends up in that first byte varies based on our half-duplex stuff. So I'm trying to get the byte that's read to be 61 instead of 00 or FF. Basically, I'm trying to... SPI is a bidirectional bus. It transmits data on one line and it reads data on the other line. I'm trying to get the reading to actually read the right value. I mean, it really feels like it's just like the wrong things connected in terms of the inputs. The other thing that might be interesting is actually seeing, because I'm doing it, this is an input check. What if I input check on 35? Because 35 is my suspected where it's reading it from. So, and let's move this down here right before we start the transaction. So 37 should be input. Okay. Do I have another unit? I do. 35. I think it's 35. Let's just try that. Thanks, Andon. And they DM'd me. They said, "Why did you mute me?" And I said, "Because you were spamming." Because you're being silly. Sorry, I'm talking to this person. That'll keep me entertained while I'm waiting for it to... They get muted for spamming, and now they ask, "What's the main focus of this server?" If you don't know what it is, then you don't need to be here. People are so silly sometimes. Alright, let's see how this looks. Well, that looks correct. It says that 35 is not an input. And that is right. How does that work? Let's pull up the technical reference manual. This may be the wrong direction of it. Stuff anyway. Is there any way that you could verify the pin's hardware is functioning properly? Yeah, I mean, I doubt it's a hardware issue. Maybe Unexpected Maker is gonna point something stupid that I'm doing out. TG Techie, did you find the keyboard? Did you want to find it? Anyone else just stick their super sharp tweezer tips 2 millimeters into their fingers, or was it just me? I did not, but I have this pair of tweezers on my desk that I dropped, and it like stuck into my foam mat that I stand on. And I was happy it was the foam mat, not my foot. Okay. Interrupt matrix, GPIO, mux. This is the handy deep dive weeds thing today. Let's zoom in. Can you see it? So this is the really interesting bit, I think. One of the cool things about microcontrollers, at least. So this is the chart that they have in the technical reference manual about how signals come from the outside inside. So there is this pad and this pad and the different supplies that they're powered off of. Great, I'm glad you found it, TG Techie. It goes into the I/O mux, which allows you to choose where the signal goes. And then, so that's if you're going directly to the peripheral. So that's if you're configured going to I/O mux directly. Otherwise, you're going through the GPIO filter and the sync, and then you go into this function input selection. Then there's inversion, and then it picks between the I/O mux or through the GPIO matrix. So, it's got to be something else. I think you're right. Like I think I'm barking up the wrong tree, because we know that this input portion should be disabled. Because we just read it and we checked it for pin 35. So it could just be happenstance that, huh. Just clean it well, I think. All right, update from the person I muted. How much time do I have left? I'm tempted to make it like 24 hours instead of 10 minutes. Sorry. Moderation. What else can I do? Why else would it be wrong? Maybe we should look at the example. Should we look at the example? Let's look at the example. Okay, so in here I think I have Spy Master. DCD says yes, the example. Okay, so bus device is polling. Set up device. So Spy setup device at the highest level, all it does is it copies all the settings over from the device level stuff into the HAL level stuff. And then calls Spy HAL device setup. No examples, that's cheating. Mark asks, did you try with DMA turned off? I did not. And that's an interesting idea. Yeah, let's try that. The reason I turned DMA on is because I wanted to support longer transactions. But for this, because we're just doing 1 byte, let's try that. I think that's a great idea. So to do that, in here, we say all of these things. Actually, I could probably just set that to 0 and this to 0. And let's try it. And also, Ibrahim asks, why bother with the ESP if a full Linux board can be had for the same price? Linux is complicated, and it's also, because it's complicated, it's not necessarily real time. So you can get better guarantees about how everything executes if you have less stuff going on. So I tend to prefer not having Linux because there's a lot more complexity there. And the Linux boards that you have usually are much higher power, and so you can't get them as lower power either. Okay, let's see what this person said. What are Adafruit? Muted them for longer. Is the RTOS layer still involved? Yes, it is. Any other change from the last PR that could be affecting this? Oh no, you know what I should have done? Ah, no problem, Ibrahim. Thanks for asking the question. Brute force or nothing. Okay, so this is interesting because the 3 was not overridden here. So 3 is here and 3 is here again. And let's just check, let's run it one more time with the CLA going. Having a large runtime from a full ROS can make things more complicated than they might already be. Yeah. And it's hard to get going too. I think like the idea of like flashing an SD card and getting it to boot up and getting your SSH settings are more complicated. All right, let's see what happened. TG Techie, yes. Doesn't CircuitPython also schedule its background tasks in a way that can make CircuitPython scripts non-deterministic? Yes, indeed. And in general, that is the case for Python everywhere, is that like at any point could you do garbage collection that would cause your timing to go out of whack. Oh, this is interesting. So with DMA turned off, I think, we can see that we're transmitting the dummy bytes that we're transmitting here are we're transmitting the D0 again, probably because it's like still caught in the buffer that's been copied. Let's also try it with half-duplex on and just kind of figure it out. So I'm going to turn this on, and then the person's still talking to me because I muted them and just didn't ban them. All right, so it's still got the 3, and let's see what this says. How did this work now? So now it's an FF because it's half duplex. Like that half duplex flag is not documented that well to me. This is correct still, so maybe it's okay to have on. But we're clearly not reading the right data back. But it is interesting that it's not reading anything back into that buffer. Which makes me think if there's something funny about if you only provide one, like maybe it writes to the same buffer over and over again. Half-duplex is simpler to debug, so I'd stick with it turned on. All right, we'll leave it on. And then the question is like, if half-duplex is on, do we arrange this send and receive buffer differently? So let's just pull up the HAL setup transaction. I think that's in this HAL IRAM. Or here's prepared data. Receive buffer. We'll copy the result out of the work registers directly later. I wonder when we do that. Can you flash real-time OS on an ESP? Yes. The ESP IDF, which is like the software the vendor provides, uses a real-time operating system called FreeRTOS. So there is one running. Okay, so I mean, this would explain why it doesn't work. If there's another step that we need to do otherwise. User start, user done. Yeah, the logic analyzer says it's still returning the 61. It still is returning the 61 here, which is good. So our transmit's not broken. So actually, let's just take a look and see here. I just realized they were backing up. I was about to open the window again. So if we just look in SpyMaster, we should be able to see what they do around user start. here. Like, kick off the transfer. Oh, here we go. Fetch result. Maybe that's what we need to call. Let's see what that does. Ah, so if there's a receive buffer and DMA is not enabled, read the buffer back. Okay, so we can do that. We should probably call that. How does that work? All right, let's see if that works. It doesn't explain why DMA is not working, but it'll get us further. They are not making a compelling argument. Why I should not mute them. Sorry, I'll not get distracted anymore. They can come back tomorrow if they want to spam. I mean, the thing is like, spammers are usually just bots, right? So, like, the bot's running, it's not going to circle back. Okay. So this is still FF. Even though I save the file, I call fetch result. It's still not right. Oh, but it is overwriting it now. Haha. So it is actually doing the same thing the DMA version's doing. Which is consistent, at least. I mean, I think it is possible. It is possible that, like, the GPIO matrix is just not set up right. Like, I think that's, like, totally feasible. If that's the case. So let's, I suspect that it, like, so the way that it works, right, is like the GPIO comes in, it's set to input, it drives a line, and that line is connected to a bunch of other lines that can be turned on in order to go to the peripherals. And if you happen to be getting the, or, wait, let's look at the picture again. In this picture, like, output is completely separate from input, though. Turn off half-duplex? Oh, now that I fixed the thing. Alright, we can try that. What if we got the D0 back? Wouldn't that be pretty wild? And Celia. Ugh. Debugging. Ugh. That's what you get paid the big bucks for. Oh man, they just dropped off a bunch more gravel over there. Alright, what do we think with half-duplex off? What do we think the value we read over SPI will be? D0! Ha! It is reading the wrong pin. That's pretty conclusive, I think. Let's look at the... Like, there's no way you're gonna get D0 otherwise. So based on the logic analyzer, we're getting D0 out, 61 in. So there's gotta be something that's messed up. I mean, what if we spend hours debugging this and then we discover like the IDF was fixed? Like, it could be a bug in the IDF, and I mean that's seeming more and more likely to me. Where like what is it called? The thing that connects, like this picture here kind of shows like function in selection is completely separate from function out. 42. Mark agrees. With the debugging you've done now, I say GPIO matrix sounds right. Yeah, it feels like it's looping back, right? Are you sure your SPI init is actually setting the MISO pin? Yeah, so I have it printing out. I have it print out the pin numbers of the MISO given to the initialize call. Triple check my work on this, but here's SPI bus initialize. It's given bus config. And then in bus config, there's a MISO IO number and a MOSI IO number. And we also know that there's got to be like a loop back, or this half-duplex thing is. I mean, the half-duplex thing, it's reading it either way, right? It's just some... It's reading it either way. It's just a matter of whether the D0 is output again. Yeah, welcome to debugging, everybody. This is what deep dives is all about. Showing the persistence and grit that it takes. I'm really hoping at this point that UARTX just works. So I don't have to do a whole nother like day's worth of work just to fix that as well. Actually, if anybody has this building, test UARTX for me, and then I don't have to do it. That would be awesome. I think it will work. And you should be able to just plug like UARTX into UXRX and just see that what you TX gets RX as well. Listening but not watching. No worries, Unexpected Maker. It's always good to have that. What does IDF stand for? IoT Development Framework, I believe. If I remember right. Because they also have an ADF, which is like an Audio Development Framework. It's somewhere in their docs. Okay, so I'm setting it with SPI bus initialize. SPI bus initialize is in SPI common. Let's pull up SPI common. Can you decode all the hardware registers that you're setting to IO max? Could you use that to force a read of FF and 00? The H-SPI and the V-SPI map to SPI 2 and 3 as well. I don't know why they have letter prefixes, but I think you can just find that in there. So, okay, so here's the stuff that's supposed to configure it correctly. Wouldn't it be funny if they just like... So this is the thing I suspect, is this GPIO matrix in, SPI peripheral signal, SPI D in, and SPI Q in. Huh. Let's see where these are. Oh no. Like, we have bugs like this all the time in... Okay, so GPIO signal map. And then in SPI peripheral, we have that. Let's pull those files up. Component sock. Components. Like, this is totally just like a copy and paste error sort of thing. Sock. SPI peripheral. ESP32. Where am I? Sock, ESP32. SPI. These are all includes. SPI peripheral. I do not know that, thank you. Mark says D equals MOSI and Q equals MISO. So I think it is putting us on SPI 3. So it is doing SPI Q in here. So let's see what that is. I mean, this should be all auto-generated. I can't... GPIO signal map. Sock, ESP32, include sock signal map. GPIO. So 73 and 74. That seems okay. We could also print out stuff here. You think we're hunting down like a silicone bug? Actually, we should check the errata. Is there an errata for this yet? The SAMD51 was like that. You'd spend tons of time and then be like, oh, I should have checked the errata. For those of you who don't know, the errata is like the documentation of the things that weren't actually correctly made in the silicon itself. Documents. I did find an error in the technical reference manual, and I filled out the like form for it. Oh, I think the construction folks are gone. Let me open the window. Oh yeah, that's cooler air. Another way, let me switch to the camera. Another way to know that it's like super hot in here is if the cat is like completely sprawled out. He's hot. All right, back to the browser stream. Did we find an errata? We did not. What? No errata at all? Like that? The other thing we could do is we could try to just use the IDF directly and see if it works there. That's one thing we could do. Another thing we could do is print it out where we think it's set. a second argument also. I don't call SPI device transmit. I'm calling the HAL equivalent. Like, I'm mimicking what that's doing. I'm not doing it directly. So, like, I'm calling setup transaction, prepare data, and user start. Yeah, I'm not calling SPI device transmit at all, but I should take a look at that. That's what I'm trying to mimic. But, like, it feels so much like it's just an IO mux problem. I wish Ivan was watching. Hi, Johnny. Thanks for jumping in. Yeah, David had a great idea of doing it without DMA. Like, it feels so much like the wrong thing is connected. Like, clearly it's reading the output. And we're in the mode that it's half-duplex. And I'm setting it early when I switch it. Half-duplex 0. Timing. Timing config is based on get clock config. Duty cycle. Input delay nanoseconds. Transaction flags, use TX data and use RX data. Okay, let's see what those do. We all know I need to listen to Mark. So let's look at SPI master again. Could I try a different set of pins? I could, Charles. I could. That's not a bad idea either. I'm losing steam. This is why I tend to work in like 2-hour chunks. Simon asks, how's lockdown in the US treating you? It's fine. I mean, I work from home, so my work life hasn't changed at all. And until my wife went to see her parents for a while, I was home with her, and that was fine. She's working from home. But, I feel like I can go to the grocery store and stuff now. I just wear a mask that my mom made me. Like a cloth mask. So, and it's beautiful out, so I get outside at least once a day. And, like, if I go for a run, I just run around people, so I'm not right next to them. So, not too bad. Sorry, we were gonna look at use TX data. Like, see, this is just check-in stuff. I don't know what it actually does. Right, so it's just saying if we use TX data, then we use the TX data pointer. And then if we use RX data, we use RX data. But I think that's all it's used for, from what I can see. So I think that's fine. Yeah, let's try a different set of pins, Charles. That's a great idea. Okay, so I'm just gonna move Misto. I'll just move it 1 over to I have it labeled RX, but I'll have to figure out what pin it is. So I have the RX on IO 5. So we're going to move it to 5. And so that means that I actually have to plug it in after I get it going. And we should be able to see that because I'm like printing it out. Prayer Horizon from Twitter asks, how long does it take to become a professional like you? Takes a lot of practice. I've been in the software industry for just over a decade, and then I got a 4-year computer engineering degree, and then I was self-taught before that. I've been programming since like 2002 or so. Okay, I'm gonna turn the USB on, and we're gonna switch it over to pin 5. Clock, Mosi, Miso. 5. Start logic. Hit save. Ah, it does the same thing. So if we look here, we get our D0 out, our 61 in, and we're reading our D0 still. Good idea, Charles. Am I a professional? By definition, yes. Right? Professional means you get paid for it. No more than that. You do app. Sure? I don't know what you mean. Well, it looks like it's still working that way. All right, let's look at the examples proper. Like, at this point, it feels like it's an IDF bug, right? Like, it feels like it's not a bug on my end. I don't know. I think you're a professional, Mark. You've been paid to do it before. I think that counts too. If it's an IDF proper bug, the way that we should report that is by not doing CircuitPython at all, building an example that should work, and demonstrating that that example does not work. So we have to figure out how to do that. This is where I demonstrate I don't actually know where the examples are. Driver. Where are the examples? Not in components, I guess, right? Here we go. Examples. Get started. Okay, those not the ones we want. Peripherals. Spymaster. HD EEPROM. How does this work? Everybody's offended that I took professional to be so literal. Yeah, Charles, it was a good idea. TG Techie asks, what would a 2-sentence summary of what you're trying to fix be? I'm trying to correct the data that I get in from the SPY transaction. The The data that I'm reading in the SPI transaction is the data being output. It's not the data coming from the device, which is wrong. Hi, Timon. So this is interesting in that I think we're running on SPI 3 and these examples are running on SPI 2. So it is possible it's like a SPI 3 bug that like maybe is a bug. Or there's like some detail about SPI 3 that I don't know. Let's look at the data sheet. Make sure that your hardware is connected to the matching pins for the example. Yep, thank you. EEPROM host. Problem is I don't have any. I don't think I have any EEPROM. And the other one is an LCD. And the LCD has a pretty effect. But I kind of assume that they do have input. They do use MISO on 37 with SPI 2. But again, like, I have a different device connected. What is the right thing to do now? I've got 2 hours of video I can post on the ESP forum. Oh, here's an idea. Let's try SPI 2. Like, we have the option of using either of one of them. And we're trying SPI 3 here. Though you have to do composition now from the unexpected baker. Yeah, my pizza could have turned out better. Let's simplify this. Let's just do SPI 3. Or, not what I said, what I was thinking. How do you decide whether it's SPI 2 or 3? So, my understanding is that SPI 2 is the only kind of available SPI that you can connect through the IO mux, which means that you can clock it up to 80 megahertz. And that's only through one set of pins. So if you set that one set of pins, it should match. But I don't think the IDF code doesn't actually do this, from what I can tell. I don't think the pins are right. So there's this whole thing of SPI peripheral signals and these pins. I don't think it's right. So I was kind of hoping to keep SPI 2 for when you like pick the right pins. But it doesn't, it didn't seem to work because I thought I had put them on there. Maybe that's because maybe because of the CS pin, I don't know. So it's still working, let me unplug. And in here we could see that MISO is at 5. So let's see if it works. Right, so DMA, or Unexpected Maker asks, you have DMA off, right? Are you sure SPI 3 supports DMA? I thought only SPI 01 had DMA, and whatever the numbering they use now. I believe they all have DMA. I have it off, but I think they all support DMA from the internal memory. I think it's only the external memory that it doesn't support as DMA. I think it's when it's external memory that it's funny. Let's just do this. And this thing I cribbed, I don't think is right. Oh, see, it doesn't test chip select, so. Although I wonder if I'm not sending, what am I setting these quad HD IO numbers to? Am I sending, okay, I'm setting a -1. Okay. Let's see if SPY2 works. Otherwise, I'm gonna have to call in some helpers. Can't say I didn't try, right? You all see me trying to figure it out. D0. D0. Don't need to be set, but they need to be set to -1, not 0. Otherwise, this stuff won't be correct. Because this is checking greater than 0. So they can't be 0, they have to be -1. Which they are. So that should be right. Something is wrong. Something is not right. So that doesn't matter either. Probably have like an off by 1 error or something, I don't know. We're almost to our 2-hour mark. Thea is on Python T at 4. Of course. I mean, I assume that it works. I wonder what the value of the TX buffer is. Wouldn't it be funny if it was putting it in the wrong place? Like if it was just writing it back. But it's null. Like, I wonder, let's try it. Why do you assume it works? It's a good question. I mean, the chip is, like, in production. You would hope that, I mean, that's what errata's for. But it is weird to me that it's both SPY2 and SPY3 have the same problem. Like, it's gotta be some matrix thing that's just not being set up right. Or like maybe it's in 3. The URL for Python T is twitch.tv/nnjaio. If I remember right. Yeah, get example to work. Peripheral is not being mapped as expected. And like, we're not using DMA because we know that it didn't work until we called this thing that works, that is geared towards when DMA is not on. It's receive buffer. Let's just keep looking. We're almost done. I'm not gonna I'm running out of brain power for it. Need to copy from SPI registers to the result buffer. GPIO 31 for MISO and 32 for MOSI. I think those are the pins that the internal flash are on, I think, right? Like, I don't think I want to do that because I don't think I would share the bus well. I don't think I'd share the flash and RAM bus very well. Because those pins I think are already used. Like I can look, but if I remember right, like not this. Schematic for the Saula. It's not what I want. I want the schematic for the module. Here we go. It's like on the schematic for the module, like GPIO 31 and 32 are these SPI D and SPI Q. And those are the ones that are connected. Like I would have to share them. So I don't want to do that. And there's a little bit of information about the SPI device here. Operate in master and slave modes in 2-line full duplex and 1-line half duplex communication modes. Do we have half duplex on still? Because I don't think that's right. We want a 2-line mode. No, we have it off. We have half duplex off. Hi, folks. We're just wrapping up. I'm stumped. Like, this is the weird thing, too. Like, reading this. Like, oh, I misread this. It doesn't make any sense to me to name a pin SPI D or SPI Q. It just throws me off. Wait. SPI 2-line mode is 2 bits bidirectional, where SPI 1-line mode is 2 lines each way. In 1-line half duplex config, I think we want half duplex. Like based on that, like it's just, I might have to get some secret access to the SPI datasheet. How's it supposed to work? I don't know. Let's see what this does. Hi, Robert and Trang. David says, the professional knows when to walk away. Yes. And that's so true, right? Like, it's so true that, like, I can bang my head against... We can all, like, collectively, like, a bunch of us are thinking about this. We can all bang our head against it for, like, 2 hours. We're almost to the 2-hour mark. And we'll all walk away, and, like, within 10 minutes, like, I'll figure it out, or somebody else will ping me and be like, hey, it's this thing. Like, that happens all the time. Like, it's so important, I think, and why I think working from home and giving yourself that space is, like, very beneficial. Like, the idea that, like, I'm gonna work for a focused 2 hours and then I'm gonna, like, let my brain relax and go do something else, like watch Python T. So we're getting the FF. So, I mean, I think this is the mode we want to be in. I still, like, this FF was the state of the wrong line. right? Like if we click logic going, I mean, so that's an option, right? Unexpected Maker says, do you really need SPI support in CircuitPython? And just remove it and move on. Well, yes, but most of the things that we use SPI for are transmit only. They're not bidirectional. Although like the SPI flash is bidirectional for sure, and SPI RAM. It's Python T with TEA as in the drink. So I don't know. I think I'm gonna have to call it. Or we could try. We could. Is this the place to get a free RGB ring? No, it is not. We are not giving a. I don't think. Were they giving away stuff during? There was a stream earlier that maybe they were giving free stuff away, but I doubt it. The other thing I could do is test UART, but I'll do that off stream. I'll do that while I watch Python T. So, thank you everybody. Sorry we couldn't have like rejoicing and like figure out that Mark was right, that I should have just looked at the example, but this is how it goes. This is real engineering. This is really deep diving. You know, we dug into the HAL layer stuff. We looked at some bits and tried to figure that out. Transactions with data not exceeding 32 bits. Oh, Mark. What does that say? When transaction data size is equal to or less than 32 bits, it will be suboptimal to allocate a buffer for the data. The data can be directly stored in the transaction struct instead. Oh, yeah, we saw that. We're not using that. That's just changing the pointer that they're passing down to the HAL layer. But yeah. Okay. If I don't figure it out, I'll ping Ivan on Monday. Because he's been a huge help. If anybody else has ideas, please just ping me on Discord. If you want to join the Discord, if you're in one of our other chats and the live stream chats disappear when the stream ends, please hop over to adafru.it/discord. Discord.gg/Adafruit works as well. That's a chat that lasts all week. Again, thank you so much for watching. If you want to see more streams from me, more streams from all the other Adafruiters, please support Adafruit. They're just getting back on their feet from losing a lot of money during the hardest period of COVID so far in New York. So buy some stuff from Adafruit.com. They do sell ESP32-S2 modules now, I believe. So if you want just the module, you can go there. We will, of course, be producing more ESP32-S2 modules or products in the future. So if you want to pre-buy for that, you can always get a gift certificate. They never expire. But that means we get the money to pay for me earlier, which would be cool. And we also have an IoT service that you can pay for as well, which is neat. So thank you all. I hope you have a great weekend. Thanks for hanging out and banging your head with me. It's kind of like a concert, banging our heads. And I'll stream next week. I'm not sure what day, because I think next weekend is a holiday weekend. And I told my parents that I would go over there, so they kind of want to see me. Let's see, the holiday is actually on Saturday. So it's possible that I might actually take next Friday off, so just keep an eye on the blog. Keep an eye on the blog, look for the deep dive stuff, and that'll tell you whether I do it on like Thursday or Friday or some other day. So thanks again, and I hope you're all staying safe, staying sane, and we'll see you next week. Cheers.